Hello everyone, welcome to today's daily Leetcode challenge. We'll be solving question 2009, minimum number of operations to make array contiguous, or continuous, sorry. I'll be going through my thought process as I come up with the solution. This current video is going to be done in Python, but from now on, I'm going to try to make Rust videos as well. It's a very cool language that is worth learning, so check that out as well. With that, let's begin the question. So, minimum number operations to make an array continuous. Cool. So we're given an integer array nums. In one operation, you can replace any element in nums with any other integer. Okay. Nums is considered continuous if both of the following conditions are fulfilled. So there's two conditions, 1 and 2. All elements in nums are unique, and the difference between the maximum element and the minimum element is equal to nums.length minus 1. So, for example, 2, 4, 2, 5, 3 is continuous, but 1, 2, 3, 5, 6 is not. Right away, in these sorts of questions where I guess the explanation is a little vague, try to really dive deep and understand what exactly they're asking me. If you are careful, you will notice that in this case, these two conditions really just dictate an array that's going to, if it was sorted, it would be a continuous array where the difference between the first element and the last element is length minus 1. So in this case, it's 4. The difference is 4. So what does that mean? Let's look at this array here, 4, 2, 5, 3. Well, a rewritten version of that is just 2, 3, 4, 5, right? Simple. And keep in mind that you can't have like a 6 here or something. The continuous here is really just like the real numbers just sliced with some start and with some end. So I hope that kind of clears up things a bit. And essentially what we're asked is, for example, return the minimum number of operations to make nums continuous. So we're given some arbitrary array. I don't know what it is, but we have to figure out if this was like a number line, like an endless one. We have to figure out where does this array fit in? Does it fit in here best? Or does it fit a little bit maybe to the right? Or does it fit a little bit to the right or to the left? We have to figure out where it has to live, right? And we're going to do that by figuring out what the minimum number of replacements has to be. So, yeah, sorry, this is a bit slow for some reason. I've drawn this and it's dragging only now. Look, no hands. Anyway, so how do I approach this problem? Well, we're given this initial array that is not sorted. Well, actually, I mean, yeah, let's look at some examples. 2, 3, 4, 5, just rearranged. 4, 2, 5, 3 has 0. There's the output of 0 because there doesn't need to be any reordering or replacement to make this array continuous. 1, 2, 3, 5, 6 has 1, and one possible solution is, I guess, 1, 2, 3, 4. 6 replaced with a 4. Or you could have replaced 1 with a 4 and had 2, 3, 4, 5, 6, right? And so you have multiple solutions there. Um, but really what we need to know, and I propose um, keeping this in mind, that we have this almost ideal like footprint that we should be following, or that we're striving towards, this endless number line that can either start at 2 and end at 5, or start at 1 and end at 1,000. You know, all of these are possibilities, but this array that we're looking for, it's really just going to be somewhere here. Maybe it shifted a little bit to the left or to the right. So, well, the first thing that I would like to do to get as close to this base is obviously sort the array. So if the array is sorted, then 2, 3, 4, 5 is almost a dead giveaway that it belongs a bit to the right. Let's see. What if there are duplicates? Well, duplicates we can get rid of by putting everything into a set first and then sorting it. But I think the idea here is going to be something along this line, that we have this array, right? With let me draw the last case where the numbers are a bit more odd. 1, 10, 100, and 1,000. We have this case where there's no unique, none of the numbers are repeating, but we have to figure out what is the best, which one of these numbers essentially is the best to keep, and which ones are better returned with or replaced with numbers that closer resemble one base that we need. And there's always going to be a base. Let us then, let me pretend that for each number here, let me have a while loop essentially. No. I'm claiming, okay, I'm gonna restart. I'm claiming that I have a queue called a DQ. That is an array. That's in Python. It's implemented as an array, and this DQ has two properties that are close to these two, but aren't one-to-one. The properties here are all elements in the no, they are those ones. No, they're not. They're not. Elements are sorted. And another property is that, and I'm just talking about this DQ right here that I'm proposing, and you'll see why I'm proposing this DQ. Elements in the array are sorted, and the difference between the first and the last elements in this DQ, the difference between is at most, so difference is less than or equal to len, let's just call it len of nums. Length of, let's say, unique nums. The nums being referred to these guys here. Element, the difference is less than or equal to elements. And so then what's going to happen? What's going to happen in this loop that I'm going to write? While, or no, let's say for for n in unique and sorted nums, I'm going to say for n in, why is it so slow? Oh no. For n in unique and sorted nums, I'm going to say that while dq, so while this guy is non-empty, and let's see, dq of is the 0th index, so the first element, minus the n that I'm about to add is greater than or equal to this difference that I've said, difference, I'm going to say dq pop left. So what is this while loop doing? This while loop is taking care of both of these rules. Elements are sorted, but they're sorted because of the for loop, and I'm maintaining a max difference of length of unique nums by doing while dq, and the difference of the first element in the dq minus the n is greater than difference. I'm going to pop dq left. Cool. What does that give me? Well, what that gives me is an ability to know, an ability to look at this length of dq, an ability to look at this length and know what is the maximum continuous, kind of like, what is maximum continuous strike or streak of numbers that are continuous, that are 1, 2, 3, 4, 5. You know, they're not like 1, 2, or they're not 1, 2, 7, 8, 9. They're continuous. And what I'm claiming now is, let's see, there's going to be like max continuous is just going to be equal to max of this continuous and the len of dq. And at this point, if I calculate this max, and again, for some reason it's slow. I almost just want to show you. Max continuous. Okay, and now it's right. Max continuous is equal to max of max continuous and length of dq. That is going to tell me what is the maximum continuous streak of numbers that I get from the nums that I get as input from this num. Yeah, exactly. And then what's left? Well, left is to return just the length of the input nums minus the max continuous. And that's it. So I've taken care of knowing what the maximum continuous array is in the input nums simply by using this dq. All right, hopefully that explains and makes sense. Let's implement it. So we have the dq, and then we have a sorted and a unique version of this nums. What is that going to look like for n in sorted? This is a function. set of nums. Let's see that we're actually getting these correctly. And I mean, there are no duplicates here, so it's gonna be a weird. It's not gonna be very visible, but 4, 2, and then we have 2, 2, 3, 4, 5. If we were to have duplicates here, then they would just be removed. But while dq and dq at 0, so the leftmost element, minus the n that I'm about to add, is greater than, let's see, or equal to, greater than, or equal to the difference. So I want to pop while, I'm always bad at these, but what is the len of nums? I'm going to say dq pop left. Great. And max occurrences. Let's set this initially at 0. It's just going to be equal to max and len of dq. Len of nums minus max occurrence. Occurrence. Hopefully this condition is correct. Output 4, max occurrence. So I did something wrong. While dq and dq minus, I want n minus dq, is greater than or equal to len nums, I'm popping dq. I forgot to append it. dq, obviously, append n. And let's get rid of this because we're reusing it a couple of times. This is the length, or the max diff, actually. The max difference that we want. And yeah, len of dq, we want that, and we want the L minus max occurrence. Sweet. Awesome. Hopefully works right away. There are extremely smooth solution. I don't know why this was a hard, to be completely honest. These are weird functions. This is one-to-one with what we did, except they enumerate. And I don't like any of these. Maybe this one, but this is one-to-one. While, yeah, no, this pretty much beats all of them. Oh, is this what we are? No. Nope. I like this one more. So, yep, please use this if you want. Keep in mind that sometimes an easier to read solution is better than something that runs a little bit faster but is way more difficult to understand. And with that, thank you for watching. I'll see you later.